So, anyone that hasn't been living under a rock for the last 3 months might have heard of a new conversational chat AI called OpenAI. There's been a lot of buzz about this. There's been a lot of fear mongering and people saying, "Oh no, this is gonna take away my job and take away everyone's jobs." And I think it's probably good to do a little summary video because I've been doing some research. And I wanna get down to the nuts and bolts and see what's actually going on in this thing and how practical it is that it's going to replace us. So here's a question that I entered into the ChatGPT, my friend G that I call him. Why can't helium be liquefied using compression expansion process? This is kind of like this is a nerdy chemical engineering question. And it's something that it's a bit complicated. It's not straightforward. And I thought, okay, well, for me, I could probably write a page or two explaining why helium doesn't liquefy in the same way as nitrogen. But we've gotten a really nice answer here in about 3 paragraphs. Basically talking, just take my word for it. Take my word for it. This is a good answer. So let's move on to what I'm going to put in this video. I'm going to talk about how the neural networks are designed. Just a kind of cursory explanation, nothing too complicated. I'm not a computer engineer or software engineer. How these things are trained as well, and is your job at risk? And leading on from that third question is, how expensive is this thing to run? Because it's only going to replace people if it's cheap to run and if it's accessible. And I don't know how much longer it's going to be accessible for, because it's not like a Google search. It's not like a Google search at all. So starting on GPT, what is this thing? It's a language neural network. Okay, so it's a neural network that's specifically designed to interpret human inputs and then give human-like responses, right? There's a lot of different types of neural networks. There's ones for coding and mathematics and physics. They aren't as difficult to train as language models, because dealing with language is a tough one. Language is tough because the meanings of words change depending on the sentence they're in, the context, right? I mean, we see this all the time. You got a word like pear. You got a pair of shoes. You got a pear from a tree. With the sentence that it's in determines what it means, and that's not even talking about colloquialisms and all those sort of nuances. So there's a lot of challenge in making a language neural network. We've seen it earlier with things like Microsoft Tay. I think in 2016 that was quite hilariously hijacked by 4chan, because it was, I believe it was what would you call it? It was like a is it a recursive language network? So basically it would learn from your inputs. I think ChatGPT is the same, but it's a bit more advanced. So you could feed it, you could give it assertions. You could give Tay assertions, and she would start to change some of her prompts to quite hilarious effect. So basically, these language neural networks are modeled on the neurons in the brain. Now, a long time ago, some guy, a long time ago, I'm talking like, late 1800s into the early 1900s, there was a guy who was super bored. He didn't have YouTube, he didn't have social media, he didn't have any of that stuff. And he decided to get rat brains and section them up and dye them to try and determine the structure of a rat's brain and how those kind of neurons were connected to each other. And, he basically found out that different parts of the brain have different connections. So going back to how this relates to the neural networks are kind of similar as well. As you can see here, this is sort of a generation of a brain, but we can look at each one of those nodes and we can basically relate it to this thing here. Okay, so you got inputs and you got outputs, right? So those dark blue ones might have several inputs. They might have single inputs, and they can have like one or more outputs, okay? And what's sent along those inputs and outputs is electrical signals of varying strength, okay? So that can be, let's say from 0 to 9 in terms of strength, right? Now, depending on the strengths of the inputs and how the neurons are arranged, that will determine your outputs. Okay, so looking at a image recognition, a basic image recognition neural network, what you're going to do with it first is you're going to feed it a lot of data sets. So that would be like you would give it a whole lot of pictures of cats and a whole lot of pictures of dogs. Okay. And it would start to get a probabilistic idea of what a cat looks like and what a dog looks like. So a cat is probably going to look super cute. It's maybe going to have small ears. It's going to definitely have a smaller snout. And it's probably going to look a bit more dignified than a dog, because dogs can look kind of stupid. I mean, that one there, is that a Shiba Inu? I mean, they're pretty cool. Yeah, so it's going to build a probabilistic idea of what a cat looks like, you know, where the eyes are in relation to the nose and maybe the ears and the shape of the face, this sort of stuff, right? And it'll use that to give a probabilistic estimation on a new image that's fed to it that it doesn't know the identity of, to say if it's a cat or a dog, right? And that's basically how this works. So, I mean, when you relate that more to language, obviously it's a lot more difficult because it's not quite so objective what your text will mean. It's much more easy with like images of cats and dogs. There's a lot of different arrangements of these neural networks. You get some really funky, cool looking stuff. Like you get this kind of like, what's that? Octagonal one that looks pretty cool. You get this one that kind of, it's like an hourglass on its side. I'm not an expert on this stuff, but it's pretty cool and it's pretty complicated. So going on to how they're trained, I did touch on this a little bit before, but breaking it down more into humans, because that's what these language neural networks are basically based off, is deep learning. There's two phases of learning or training. There's unsupervised and supervised. So the unsupervised is learning the basic of getting the basic data set. So for the image recognition, that would be giving it categorized pictures of dogs and cats. In the context of like a human, that would be just like talking to a baby. So a baby starts to, you know, learn how to enunciate and talk without getting feedback from the parents, so to speak. So the parents will talk to it and it'll start to learn how to make sounds that sound like words. And that'll go on for, you know, I mean, what, like 5 or 6 years before they start to talk. Then they'll go into school and they'll start to undergo supervised training, which is like fine-tuning, optimization, where the responses are graded and optimized. So, you know, a kid, if he studied for the test, he'll get a good result. If he studied a certain way, maybe he might get a better result than if he studies a different way. And then from that, the kid can determine whether or not he's learning correctly, right? So in the case of a neural network, supervised would be humans grading the responses. And this is especially important in the case of language networks. So if you don't have this, then you're going to have a lot of nonsensical sentences, right? So when there's like low scores on a response, that means that the particular neural path that was used to generate the response needs to be changed, because you're talking nonsense, mate. Higher scores will reinforce the existing neural arrangement network. So going on to the big point that everyone's worried about, right? Is your job at risk? And I'm gonna ask a few questions here. Do you like to use your hands for things? Do you like to weld? Do you like to lay bricks? Carpentry? Do you like to drive big diggers? Then I would say no. I would say your job is not at risk. Probably not for a wee while, at least, anyway, as far as we can predict. Do you do something with your hands other than typing? Maybe if you're a doctor or a nurse. I don't see that happening either, because, you know, robots are really expensive. But something that we've already seen happen is if you're a mediocre digital artist and that is how you make a living, then you might be in trouble, because these AI systems, not ChatGPT, but things like Dolly, are already giving artists a run for their money. If you're particularly skilled, I think you'll be fine. If you're in that top 10%, I 10 to 20%, I think you'll be fine. But if you're not, you have to start using these things to improve your outputs, I think. Another one would be, do you sit in a corporate job and write irrelevant reports and memos on corporate social responsibility? Then I think you might be in a bit of trouble there, because this thing is really good at reading through tens of thousands of textbooks and writing nice summarized report sections. So you might be in a bit of trouble there. So let's look at the hardware here. And this is one of the reasons that I don't think everyone should be super concerned about this ChatGPT, right? So to make the latest iteration, which is ChatGPT 3. No, it's GPT-3. If I'm correct there. So it took about 1 year of unsupervised learning on a Microsoft supercomputer. It took about 45 terabytes of data from what I read. So that's like textbooks, anything on the internet that was text and written since, I think, 2021, because that was when they started doing the learning from the data sets. It's gone through all that and used that to build probabilistic networks of, what it should be outputting in terms of text, right? And it's been using some really, really nice hardware. NVIDIA V100 GPUs. These things are expensive. Okay, they're about 10 grand each, and they typically come packaged in like server modules. So like, I think there's multiple ones in there. There can be like 6 or 8 of these GPUs, these V100 GPUs. Per module, and supposedly it used 10,000 of them. Now they cost, from what I saw online, about $10,000 each. But maybe with a bit of discount, we're probably looking at like $70 or $80 million there just in hardware. And then there's 285,000 CPU cores, which are like used to support the GPUs. And I mean, what does a Xeon CPU have? Is that like 8 cores? So is that like 30,000 Xeon CPU? So is that like 10,000 per Xeon CPU chip? This is expensive. I think we're already looking at, $300-400 million here on this Microsoft supercomputer. It had about 400 gigabytes per second bandwidth, which I think that's about, what is that, about 40 Ethernet cables? Maybe I'm wrong on that. It's quite a bit of bandwidth. So most of the work is done on CPUs, just like in gaming. You get a modern game, you're going to find that it needs a fast graphics card more than it needs a fast CPU in most cases. So then what happened is, once they trained all the data, they got humans to judge its text output. So they get humans to give it inputs and then score the outputs, right? That's to make sure that the neural network has been optimized and isn't giving kind of gobbledygook nonsensical answers, or answers that don't make sense or that have bad grammar. So far, I've given ChatGPT about 20 inputs on various complex answers, and I haven't seen any grammatical errors, which I think is pretty impressive. So they've done a good job. So it's taken about 1.5 years of various training to get this GPT 3.0 to where it is now. Now for the operating, because the neural network has been frozen, right? It's not going to need the same level of hardware when it's being accessed by, say, one person. But the problem is that when you got millions of people giving it inputs, it's a different story altogether. So supposedly for the operating hardware, it's using the next generation of NVIDIA graphics cards, which are A100s, which I think are about 20 or 30% more expensive. And it's using tens of thousands of these currently. This is all part of the Microsoft Azure cloud computing. So Microsoft gave them $10 billion in investment. And it wasn't $10 billion in cash. It was actually $10 billion in cloud computing credit. So that's what they're using for their PR and research that they're doing right now, but letting everyone use it. So according to Semi-Analysis channel on YouTube, this was costing about $700,000 to $1 million a day in computing costs in terms of the cost of the hardware and the cost of the electricity. So it's this ChatGPT is expensive. You know, a Google search might be fractions, like 1/100th of a cent, and a ChatGPT query will be closer to about 2 or 3 cents, which is pretty expensive. You have millions of people using that for long periods of time. That's really going to hurt your your operational expenses. So, all in all, I think